Okay, so good afternoon, dear students. See, in the last class, we have started the that is the third module, association analysis. So in that, we have seen some of the basic concepts in the last class. That is, what is the definition of association analysis that we have seen. I'll just repeat that. See, association analysis, it is mainly used by the business owners or the retailers in order to improve their business and in order to improve their marketing promotions and then customer relationship, inventory management. So they will be performing this association analysis. So it is mainly used to find the interesting relationships that are hidden in the large data sets. So with the help of this association analysis, we can find some of the interesting relationships which can help the retailers or the business enterprises to improve their business. So that can be done with the help of association analysis. Okay, and then we have seen the binary representation of a market basket data in the last class. Okay, so now coming to the next topic, that is item set and the support count. So we shall study about the definition of, so what is an item set, okay, and what is the support count. Okay, so now coming to the items here. So in the last class, see in this example, see we have total, so if you look at the total number of items here, so it is total 6 items. Okay, so in general, see the total number of items, all the items in this market basket data, so we will denote that by I here. So capital I stands for all the items in the transaction of the market basket data. So we have taken it as I is equal to I1, I2, and then IT. See, these are all the items which are present in general in the transaction or the market basket data. So here in this example, totally we have got 6 items here. Okay, so in general, we have specified it as I1, I2, and then I2. Okay, and then now coming to the transactions, the total number of transactions is denoted by capital T. So that is equal to T1, T2, Tn. So this is the total number of transactions in the market basket data. So if you come to this example, see total number of transactions here, it is 5, 1, 2, 3, 4, 5. So T1, T2, T3, T4, T5. So total we have got 5 transactions in this example. Okay, in this table. So here, so in this in this denotion, we have considered the total n transactions here, T1, T2, and then Tn. Okay. So now coming to each of the transaction here. So any transaction here, it will be containing the subset of items, and these items will be chosen from the set of items here. So if you consider any transaction here, in general TI, so in that transaction, there will be a subset of items. And these subset of items, they will be chosen from the given set of items here. So we will choose those items from all the given items. Okay, so that is called as the transaction. So here, for example, if I consider any transaction here, see this transaction one. See, transaction one contains 2 items here, bread and milk. See, these 2 items we have chosen from the list of items. Totally, we have got 6 items here. So I had shown that. So totally, we have got 6 items here. See, from these 6 items, see, in order to form the transaction T1, we have chosen 2 items, that is bread and milk. So each of the transaction, it will be containing a subset of items, and these items are chosen from the given list of items. So each transaction is a collection or subset of items. Okay. So this collection or subset of items, the transaction which contains a subset of items, that is 0 or more number of items, so that is called as an item set. So in case of association analysis, say item set is nothing but it is the number of items which are present in the transaction. It is a subset or collection of 0 or more items here. Okay, so see here, all these are item sets. Okay, bread and milk, bread, diapers, beer, and then eggs. See, all these are called as item sets. See why they are called as item sets? Because they contain 0 or more number of items here. So each transaction contains 0 or more number of items. So such kind of items, okay, so collection of items, it is called as an item set. So item set is nothing but it is a collection of 0 or more items. Okay, so in general, if an item set contains k items, then that item set is called as k items. Okay, so if you have got 2 items in the transaction, then that is called as 2 items because it contains 2 items here. So if it contains 3 items, then that item set will be called as 3 items. In general, if the item set contains k items, then it is called as K item set. So I will show you the example here. So this first transaction, see, it is a 2 item set because it contains 2 items in that transaction, bread and milk. So second one, see, bread, diapers, beer and eggs. See, it contains total 4 items. So it is 4 items. And next one is also 4 item set. All these are 4 item sets. So the number of items which are present in the transaction, so it is going to specify the size of the item set. So one more example is, so see here, beer, diapers, milk. See, this item set contains 3 items here. So only it is a 3 items. So item set is nothing but it is a collection of items here. So how many items are present in a transaction? So that is called as an item set here. Okay, so in general, if there are k items, then that is called as k items. Okay, and the null item set or the null set, see, or the empty set, it will be containing no items in it. Okay, so null set doesn't contain any of the items. Okay, so zero item set or null item set is an item set that does not contain any of the items here. Okay, so if there are 2 items, then that is 2 items. Okay, now coming to the transaction bit. See, transaction bit is nothing but it is the number of items present in the transaction. See how many items are present in the transaction, that is going to specify the transaction bit here. Okay, so see here, see in these transactions, see transaction bit of transaction 1 is, it is 2 because it contains 2 items here. So bread and milk, 2 items are present. So transaction bit of transaction 1 is, it is 2. And in the same way, transaction bit of transaction 2 is 4 because it contains 4 items here. That is bread, then diaper, beer, and then eggs. And next, third, fourth, and fifth, again they are having the transaction bit that is 4 only because all of them contains 4 items. Okay, so transaction bit is nothing but it is the number of items which are present in the transaction. Okay, so now we are going to say that this transaction Tj. Okay, so Tj is a general that is the transaction here. See, this transaction Tj, it is going to contain an item set X if this X is a subset of Tj. Okay, so for example, see in this, if I take the transaction that is 3, see it contains the 4 items here. Okay, that is milk, diapers, beer, and then coke. Now I'm going to say that this diapers comma beer, if I consider this subset, diapers comma beer, okay, then it will be called as a subset of the transaction T because, okay, just mute your mic first. Okay, so see here, the transaction, this transaction 3, it contains the subset that is diapers comma beer. So diapers comma beer, so it is present in the transaction 3. So we are going to say that this subset, okay, it belongs to this transaction 3. If that item set, if it is present in the transaction, okay, so then we are going to say that that item set is a subset of a transaction. Okay, or it belongs to the transaction. So in general, see if the transaction Tj, if it contains the item set, okay, then that is denoted as X here, then we are going to say that, see, it is a subset of Tj. Okay, any items which are present in the transaction, they will be subsets of the transaction. Just remember that. Okay, so now coming to the one of the important property of the that is item sets here, that is called as a support count. See, support count, it is one of the very important property, okay, of the items here. So support count stands for, say, in how many items, sorry, in how many transactions that item is present. Okay, so that is called as a support count of an item set. So in general, if you consider any item set X here, see, support count of item set is denoted by sigma of X here. So it is nothing but the number of transactions, the number of elements. See, we will be finding with the help of mod here. So mod stands for number of elements in the transaction here. So transaction stands for Ti. In general, we have written it as Ti. Okay, such that this item set should be a subset of that transaction. If that item set is present in the transaction, okay, then that will be considered as one count in the support count. So just remember, transaction support count is nothing but it is the number of transactions in which that item set is present. So in total, how many transactions, see, the item set is present, that is called as a that is support count of an item set. Okay. So I will give you example, you'll understand it. Just try to remember this formula. Sigma of x is equal to number of transactions. So number of transactions is mod of ti. Okay, so this is going to specify the number of transactions. So in how many transactions that item set is present. Okay, such that, see, this item set must be a subset of that transaction. If that item set is present in the transaction, then we will consider its count as one. We will take the count of that in counting the support count. If it is not present, that will be considered as zero. And this transaction will be a subset of all the transactions, that is capital T. Okay, so if you look at the example, you'll understand it. Okay, so see here. So in this, see, same thing given, that is item set. See, item set is nothing but collection of one or more items. See, same definition I'm repeating here. Item set is nothing but it is the collection of one or more items. See, for example, milk, bread, and diapers. This is also one of the item set because it contains three items here. So it is a three item set. In general, if there are k items present, then that is called as a k item set. So an item set that contains k items, that is called as a k item set. Okay, so for example, this one is called as three item set because it contains three items, that is milk, bread, and diapers. Okay. So next, coming to the support count. Okay, so in case of support count, I told that, so it is the total number of transactions in which that item set X is present. So that is the frequency of occurrence of an item set. So in how many transactions the item set is occurring, with what frequency, that frequency is going to denote the support count of an item set. So example, so milk, bread, and diapers, if you consider this item set here, so milk, diapers, and bread, in how many transactions it is present. So this milk, bread, and diapers, it is not present in the first transaction because we need to consider all three items here. So milk, bread, and diapers is not present in the first transaction. Just leave it. Next, check in the second transaction. Milk, diapers, beer. Sorry, bread. It is not present in the second transaction also. Next, go to the third. Milk, bread, and then diapers. See, it is also not present. Next, see in the fourth and fifth transaction. Okay, milk, bread, and diapers. It is present, right? Milk, bread, and diapers. It is present in the fourth transaction and also in the fifth transaction. Milk, bread, and diapers. So since it is present in the two transactions, see, the count is two here. So the support count of this item set, okay, milk, bread, and diapers is equal to 2 here. Okay, so in the same way, if you consider the support count of bread and milk, so in how many transactions it is present? Bread and milk, one. Okay, and then it is present in fourth transaction, bread and milk, and then bread and milk. So it is present in 1, 4, 5. That is three. In three transactions it is present. So support count of bread and milk is 3. So support count is nothing but, see, in how many transactions the item set is going to occur. That is going to specify the support count. It is the frequency of occurrence of the item set. Okay. So now coming to the support. Okay. So support is calculated by dividing the support count of the that is item set by the total number of transactions. So it is the fraction of transactions that are going to contain the item set. That is support. Support count is, it is the count of the transactions where the item set is present. Now, if you consider just support, the support is nothing but it in how many percentage of transactions the item set is present. That is called as a support. So support is nothing but it is the fraction of transactions that contain an item set. For example, say support is denoted by S here. Okay, so support is equal, support of this milk, bread, diapers is equal to, see in how many transactions this milk, bread, and diapers is present. So it is present in two transactions, that is 4 and 5. Milk, bread, and diapers, it is present in 4 and 5 transactions. So support of that is, support count of that item set is 2 divided by total number of transactions is 5 here. The total number of transactions is 5. So that 2 by 5. So it is the support of this item set, milk, bread, and diapers. Support count is just 2. See, support count is in how many that is transactions it is present. So it is present in 2 transactions, that is support count. Now coming to just support, see, support is nothing but in how many percentage of transactions this item set is present. That is fraction of the transactions in which the item set is present. That is nothing but the support here. So support of this milk, bread, and diapers is 2 by 5. So that is going to give me the support of this. So for example, if I consider one more, bread and milk. So what is the support count of bread and milk here? So in how many transactions it is present? Bread and milk, 1, and then it is present in 4 and 5. So total 3, that is the support count. 3 divided by total number of transactions is 5. 1, 2, 3, 4, 5. So 3 by 5 is the support of this, that is item set bread and milk. Don't get confused here. Support count is, it is the count of the number of transactions. Support is the fraction of the transactions in which that item is present. In order to find the support, we need to divide the total number of transactions in which the item set is occurring by the total number of transactions. Okay, so that is the support. Okay, so now coming to the frequent item set. See, a frequent item set is nothing but, see, it is an item set whose support is greater than or equal to minimum support threshold. See, user is going to specify the minimum support threshold here. So for example, say I will say that, see in this example, see you will get 2 by 5. Okay, so that is value is you'll get it as 0.4. So 0.4 is the value, that is 40%. Okay. So minimum support user is going to give as that is 50%. Okay. So minimum support given is 50%, but the calculated value of the support is 40%. Okay. So since this support which you have calculated, it is less than the minimum support, it will not be considered as a, that is frequent. So item set is going to become frequent if it is going to satisfy the minimum support threshold. If it is greater than or equal to minimum support threshold, then only we are going to consider it as a frequent item set. So in this example, if the minimum support is 50%, the given user value is 50%, but here for this item set, you have calculated the value, that is 2 by 5, that is 40% you are going to get. Since this 40% is less than 50%, it will not become a frequent item set. So frequent item set is an item set whose support will be greater than or equal to minimum support threshold that is given by the user. So now coming to the next thing, that is association rule. Okay. So till now we have seen what is an item set, then what is the that is transaction bit, and then we have seen what is the support, and then what is support count. These are all the things we have studied. Now coming to the association rules. See, association rule will be expressed in the form of implication here, that is x implies y. So x implies y stands for the association rule, implication rule it is. And here both the x and y are the item sets. I'll give you the example, you'll understand it. See, association rule will be present in the form of an implication here. It is an implication expression in the form of x implies y, where both these x and y are item sets. And also, say one more thing is, see, whenever you consider the intersection of these two item sets, that is x intersection y, it must be disjoint. Disjoint means that whenever I consider the x intersection y, it must be equal to a null set. That is the condition that must be satisfied by these two item sets here. So association rule will be expressed in the form of an implication expression, that is in the form x implies y, where both these x and y are the item sets here. So both x and y are the item sets here. Okay. And these item sets, they must be in the form such that whenever I consider the x intersection y, x intersection y stands for common elements. So x intersection y must be equal to a null set. That is, there must not be any common elements in these two subsets, that is x and y. Then only we can express that item sets in the form of implication rule, that is x implies y. For example, so among these transactions, I can express one of the rule here, that is milk and diapers implies beer. So if you look at this association rule, see, if I consider the intersection of these two, milk, diapers, and then beer item sets, it is null set because we don't have any common items among these x and y. So only it is going to form an association rule. So association rule will be present in the form of an implication here. So that implication will be containing two item sets here, x and y, such that whenever we consider the intersection of these two item sets, x and y, it will be equal to a null set. Okay. So in the same way, bread employs milk. So bread employs milk. So that is also one kind of a association rule because intersection is again null set. Okay. So now see this association rule. In order to determine its that is confidence, we will be that is in order to determine its that is properness, we will be using two metrics here. So one is support and second one is confidence. Okay, so it will be used to determine the strength of the association rule, or how much useful this association rule is. In order to find that, we will be using two that is parameters here. One is support and second one is confidence. So strength of the association rule or usefulness of the association rule, it will be determined by two metrics or the parameters here. So first one is support and second one is confidence. See, support we will be calculating using this equation. Support of that is this rule, x implies y, s of x implies y. So it will be equal to support count of x union y by total number of transactions. See, I need to consider the union of these two item sets x union y and then determine in how many transactions it is present. Sigma of x union y stands for in how many transactions that item set x union y is present. That is numerator divided by total number of transactions. If we divide that, then we will get the support here. So support of yes, that is x employs y. So it is equal to sigma of x union by divided by total number of transactions here. And in the same way, confidence of this rule, that is x employs y, it is determined by considering the support count of x union y divided by support count of x. Okay. So try to remember the difference here. Support is different, confidence is different. Okay. Support is determined using this equation. The support of this x employs y is determined by considering the support count of x union y divided by total number of transactions. That is support. Then confidence is confidence of x employs y. This association rule, it is denoted by sigma of x union y divided by sigma of x. That is the confidence of this rule. See, support is nothing but, see, it is used to determine, see, how this rule is applicable to a given that is data set. Okay, so how much important this rule is, or to how many transactions this rule is applicable. So in order to determine that, we will be using support here. And confidence is used to determine, see, how frequently this item set X is going to occur in the transactions that is going to contain Y. It means that, say, how frequently these item sets X and Y are going to appear together. That will be specified with the help of confidence here. So it is going to determine what is the frequency with which this item set X is going to appear with the item set Y. That is confidence. Support is used to determine, see, how much this rule is applicable to a given data set. Okay. So now see here. So I'll repeat the definitions. So two of the metrics or the measures which are used to determine the strength of the association process. One is support and second one is confidence. See, support is going to specify in how many fraction of transactions these items set X and Y are going to appear. Okay, so it means that, see, how much that is applicability of this given rule is to the given data set, or just in simple words, it is the fraction of transactions that are going to contain the both the item sets X and Y. Confidence is, so it is going to measure how often this item set Y is going to appear in the transactions that is going to contain X. It means that it is going to determine how frequently both these item sets X and Y are going to appear. That will be determined by confidence. Support is going to specify in how many fractions of the transactions both these X and Y are going to appear. Okay, that is the support. Okay. So now see here example. So let's find the that is support of these rules here. Okay, so rule is milk comma diapers employs beer. So this is the rule here. Okay, so now I want to find the support of this rule. So in order to find the support of this rule, so I told that we need to use this equation. That is support is equal to sigma of x union y by n. N stands for number of transactions. So now coming to the sigma of x union y. So if I consider the union of these two subsets, that is x and y, so it is going to form milk, diapers, and then beer. That is the x union y. So I need to consider the support count of this x union y, that is milk, diapers, and beer. So what is the support count of milk, diapers, beer? Support count of milk, diapers, beer is nothing but in how many transactions it is appearing. So milk, diapers, and beer, if you check here, it is not present in first transaction, not in the second also. Next, third one, milk, diapers, beer, it is present here. And then milk, diapers, beer, it is present in fourth transaction also. Next, in the fifth, milk, diapers, beer, it is not present in the fifth transaction. It is present in only two transactions, that is 3 and 4. So now if I consider the support count of this milk, diapers, beer, that is x union y. So x is this one and y is this one. So if I consider the union of these two, it will become milk, diapers, beer. So support count of this is 2 divided by what is the total number of transactions? Total number of transactions is 5. So 2 by 5 is 0.4. That is the support of this rule, that is X employs Y, milk, diapers employs beer. Okay, next in the same way, confidence equation is, so see here, confidence is sigma of X union Y divided by sigma of X. Support count of X union Y by support count of X. Now if I find that support count of X union Y is same, that is milk, diapers, beer, that is X union Y. So support count of this is already we have found, that is 2. Next support count of X is, X means LHS part, milk comma diapers. So what is the support count of milk comma diapers? So milk comma diapers, in how many transactions it is present? Milk comma diapers, if you look here, milk diaper, it is present here, and then 2 and then 3. It is present in 3, 4, 5 transactions. So support count of milk comma diapers is 3. So numerator value is 2 by support count of milk comma diapers is 3. So 2 by 3 is 0.67. That is the confidence of this rule. So support count will be calculated using the support count of the union of these two subsets divided by total number of transactions. That is support of this rule. And confidence is determined by considering the support count of union of these two transactions, item sets divided by support count of this LHS, that is X. Okay, so that is going to determine the confidence. Okay. So now coming to what is the use of using this support and confidence. Okay. So the main reason for using the support is, see, we want to find which are the interesting rules and which are the uninteresting rules. It means that we want to find, say, which are the items which are very, very important for my business and which are the items which are not important for my business. So in order to find that, I need to use the support. So as you know that support is going to mention, say, what is the fraction of the transaction that is going to contain those items X and Y. So if I find in how many transactions those items are present in the transactions, I can easily say whether it is a interesting item or not. So in order to find that, we can use the support. So with the help of support, we can find the uninteresting rules or the items, okay, in order to improve our business. Okay, if that rule is uninteresting, then we can easily remove that rule or an item from our store. Okay, so that we can improve the quality of the other items. So support can be used to eliminate the uninteresting rules. And coming to confidence, say confidence is used to measure the reliability of the inference that you will be making by the rule. Reliability means that, so what is the inference I can make? Okay, so how much reliable it is. So inference means that, for example, in the previous rule, I told that, see here, this rule means that milk comma diapers employs beer. It means that whenever the user buys milk and diapers, he is also going to buy beer. That is the meaning here. If the user is buying milk and diapers, then he is also going to buy the beer. So what inference I can make here? Say if user is buying milk and diapers, if he is buying beer, then what I can do is I can keep all these items together so that the users can buy all the items and I can improve my business. So the inference I'm making here, that is, these are the frequent items. So that inference I can make with the help of confidence. So it is going to measure the reliability of the inference that we will be making. That is, it means that, see, the rule X employs Y. See, if the confidence of that rule is high, then it means that, see, in most of the item sets, both these X and Y, they are going to appear very frequently. That is the meaning. If the confidence is higher, then means that they are going to appear in more number of transactions together. For example, in the previous example, we found that 0.67, that is the confidence of this rule, milk comma diapers employs beer. So the confidence says that, see, whenever that is the user is going to buy these two items, milk and diapers, is also going to be buy the beer. That is the meaning here. Since it is 67% here, in most of the cases, see, these items will be purchased together. That is the inference I'm making. So that is the use of using the confidence here. So support can be used to find the frequent items or the interesting items, and by finding the uninteresting items, we can improve our business. We can remove those uninteresting items and we can improve our business. And confidence is used to again improve the business only. Here we will be inferring the some of the that is knowledge from these rules here. So if there is a rule which is having high confidence like X employs Y, then it means that both these items are going to appear together in many of the transactions. That is the inference here. Okay. So now coming to the association rule mining concept here, that is how we are going to perform the association analysis. So in case of association rule mining, see, we will be finding all the rules here which are having the support which is greater than or equal to minimum support threshold, and confidence which is greater than or equal to minimum confidence threshold. See, association rule mining problems, in case of this, we will be having a set of transactions here. So capital T is the set of transactions. See, in this problem, or in case of association rule mining, see, our main aim or goal is we want to find all those rules which are having support which is greater than or equal to user specified threshold, that is minimum support threshold, and confidence which is greater than or equal to minimum confidence threshold. If these two conditions, if they are satisfied by the rules, then we are going to say that these rules are important or interesting rules. So in order to find that, we will be using the association rule mining. So I will give you example later. You'll understand it. Just try to remember the main motive in case of association rule mining is we want to find all those rules which are having the support which is greater than or equal to minimum support, and confidence which is greater than or equal to minimum confidence. Okay, so that is the main aim of performing the association analysis here. Okay, so now coming to one of the method which we will be using in order to find the association rules here, that is brute force approach. Okay, so in case of brute force approach, we will be finding all the association rules here. Okay, so all the association rules we will be mentioning here or listing here. Okay, so we are not bothered whether it is satisfying the support or confidence. Initially, we will be mentioning or listing all the association rules here. Later, we will compute the support and the confidence of each of these rules. Okay, so then we will be comparing the support and confidence with the minimum support and the confidence which is given by the user. If the support and confidence of these rules, if it is greater than or equal to these minimum support and minimum confidence, then we can remove those rules which are not interesting, which are less than or equal to this minimum support and confidence. That is called as pruning. Okay, so we will be removing all those rules which are not having the support and confidence which is greater than or equal to minimum support and minimum confidence. If it is less than these values, we will remove all those association rules. Okay. Okay, so now we will stop our that is the approach of finding this association rules here. So in this method, say we will find all the association rules, we will list all the association rules, and then we will compute the minimum, sorry, support and confidence of all these rules, and then we will compare the support and confidence with the minimum support and the minimum confidence. If the support and confidence of these rules, if it is greater than or equal to minimum support and minimum confidence, then we will consider those rules as the interesting rules. Suppose if it is less than or equal to minimum support and minimum confidence, less than that value, then we will remove that rule because it is uninteresting. Okay, so this is one of the approach. There are many other approaches also. I will explain that. Okay, so we have got only 2 minutes now. Okay, you just do one thing. You log out and re-log in again just for 10 minutes. I'll repeat the, I will just explain some more concepts. Just log out and log in.